Hello, and hey, ladies and gentlemen. I am Professor Jellyfish, and welcome to another part of realism review of Subnautica. This is a series where I will be examining the creatures in Subnautica and try to figure out how realistic they are when compared to real-life animals. This is a series that will not only look at the design and look at the creatures, but it will also consider the biomes and environments that they are found across in the game's world. This time we will be looking at the floater. As per usual, let's get started by going through the in-game databank to discover what information we have about the floater. This is somewhat of an unusual creature as it is made up of multiple organisms. The inner pink organism with a mouth on the underside is the dominant creature that is able to attach itself to other organisms in order to get nutrients. The outer membrane is made up of microorganisms. Essentially, the outer layer is made up of a collection of hundreds, if not thousands, of microorganisms that work as a collective in order to form a vacuum seal around the dominant creature's mouth. Between the inner creature and the outer layer there is a collection of helium which causes the floater to have a very high positive buoyancy. It is also shown that later in its life cycle the floater seems to be able to grow to rather enormous size. It is also described as being a parasitic organism that attaches itself to other organisms like the reef vac and is able to hinder its movements significantly. Now, the floater doesn't exactly look like anything on our own planet, which makes it hard to make any comparison or correlation to determine how realistic it is. But there are some animals that have attributes that resemble the floaters. One of the immediate that comes to mind is the sea urchin, but there are numerous key differences between the two. For one, the urchin is an organism that is far harder in terms of its structure. It is part of the echinoderm, which means it has something called a mesodermal skeleton, a sort of skeleton that exists both on the outside and inside of the skin, which makes it in this case very spiky. And of course, the floater doesn't have anything that resembles that. If anything, it seems to resemble the jellyfish more. But comparing it to a jellyfish doesn't work either, because jellyfish is just one organism, and no jellyfish on Earth has gaseous content inside of its body, or at least not any creature within that genus. Instead, we need to look at something else, and a creature that is rather unique for our own planet. We need to look at the Portuguese man-of-war. This is a very strange organism because, like the floater, it is more than one organism. The Portuguese man-of-war and the floater are something called colonial organisms. The Portuguese man-of-war is made up of a collection of organisms called zooids. These zooids are specialized and cannot function without one another. Some have argued that this may be the first case of advanced organs being formed in multicellular organism. But then again, some argue that this is not the case, and the other side will passive-aggressively disagree, and thus the beautiful process of scientific argument begins. But that is for another time. What does this have to do with the floater? Well, it sets a precedent for multiple organisms working together and being unable to survive without one another, and that in part makes it rather believable and realistic for the floater to exist. But this is only one aspect of the floater, and there's a lot more, and trust me, this will not be one of the organisms where I find much realism in this helium-filled pink balloon. The floater is, as previously stated, a parasitic organism. So first of all, what does it mean for an organism to be parasitic? A parasitic relationship between two organisms are classified as a symbiotic relationship where one creature lives off the other and causes it harm without giving it any benefits. So that fits the floater rather well, as it seems to be eating off the organisms it attached itself to. This goes into the question, what kind of parasite is it? Well, of the 6 major parasitic strategies, the floater fits best into the parasitoids. Parasites in this group can be likened to predators that slowly devour their prey, and considering its design, it's not hard to imagine this organism slowly devouring whatever prey it attached itself to. Considering some of the behaviors that can be observed in-game, it is an incredibly aggressive parasite, considering it is more than willing to attach itself to creatures smaller than itself. When it does attach itself to a creature smaller than itself, it will start floating upwards, which moves me on to the next part and problem of this creature's biology. As you can see, the floater floats very well, and it is in constant need of attaching itself to other organisms or hard surfaces like rocks. This is a very large problem for the floater, because if it is not able to attach itself to something, it will float to the surface and presumably die or be eaten by a bird-like predator. This means it is essentially cannot let go of whatever it has attached itself to. For an animal that is a parasite, this becomes a big problem, because parasites will eventually kill their hosts. This will mean that soon as the floater has killed its host, it will become extremely vulnerable to predators, both when it has detached itself from the host, but also when the floater eventually reaches the surface. This means that the floater has an extremely flawed strategy for finding and attaching itself to host, because it leaves itself vulnerable for long periods and is in extreme danger of being attacked. Now, from observing its behavior in-game, it does seem to have a means of swimming short distances. It would seem to use this in order to attach itself to potential hosts when it senses them. But the problem here is that the floater doesn't seem to have any means that it can use as a means of swimming or propelling itself. I say this because it doesn't seem to have any fins or any other visible means of propulsion. This sure makes me wonder how it is able to move around so quickly as it is shown in game. This I would not consider realistic for the floater being able to move much quicker than it should considering its designs. A rather effective change to the floater would be a means of adding a siphon on the back end of the floater's body. This would mean that it might use it as a means of propelling itself by pumping water through its body. Considering the size that the floater is able to grow to as well, I find another strange problem. To grow to that size, the floater would need to gather a lot of nutrients and it would also need to live for a very long time. This process brings on some new issues with the floater. First, most parasites usually don't grow larger than their hosts. The reason for this is because parasites live off their host and thus cannot survive without them. It is not in the parasite's best interest to kill its host too quickly nor to grow too fast. Rather, they should want to keep their hosts living in a weakened state, but not so bad that they cannot survive. Of course, there are exceptions to this. A good example are the wasps that put eggs inside the bodies of other insects that later burst out of the insects and devour it. The difference here is that the larvae need to eat the insect that they used as a host in order to move on to the next part of their life cycle. This does not appear to be the case for the floater. The size that the floater can grow to seems to imply something rather interesting though. In most organisms, the energy gathered from consuming nutrients is spent on just maintaining the body as it is and on movement. This is why it is so crucial for most animals to become streamlined when they are actively swimming through the water. Energy is of course spent on healing injuries or fighting potential diseases that the animal might have caught. Animals that don't move throughout most of their life cycle of course don't have this problem. The problem they suffer from though is that the amount of nutrients that is available to them will be determined based on whatever passes them by that they are able to catch. Those are the major strategies that organisms that either swim around or are stationary have to adjust to. The question then becomes, which one does the floater fit into? Well, it seems to be a little bit of a middle ground. Because the floater can sit stationary on rock faces, but it is also able to swim around in order to latch on to potential hosts. It would therefore seem that the floater spends most of its life cycle stationary and it only moves around when it needs to change host or when it discovers a potential new host. One can therefore assume that the floater minimizes the amount of energy that it spends in order to maximize how long it can spend in this state. When it finally moves though, then it would presumably spend a lot of energy in order to catch and attach itself to the host. The problem that then arises is if the floater is not able to latch on to a potential host, it will risk floating to the surface and then become stuck up there and become more vulnerable to potential predators. This leads me into another problem with the floater. It doesn't seem to have any means of independently regulating its own buoyancy. Buoyancy is something I have discussed in the previous episodes, and I feel it is time to clarify why it is so important for underwater creatures to regulate their buoyancy. Unlike us humans who want to stay on the surface and thus always want to be floating because we can't breathe underwater, organisms that live underwater have to constantly try and maintain buoyancy that ensures that they are neither sinking nor floating. The means by which they do this does of course vary greatly between different groups. Normal bonefishes usually have a bladder with gas that they can either fill or empty depending on whether they are going up or down. This makes me realize I have to elaborate on why and how water pressure changes with depth. The effect of this you might have experienced if you ever tried swimming towards the deeper ends of a swimming pool. You might have felt a pain inside your ear. What you felt was the buildup of pressure inside your eardrums that increases the more water is above you. These effects get amplified the more water is above you. This means when organisms move up and down the water column, they have to constantly adjust for the water pressure to make sure that they don't sink or float uncontrollably. The floater does seem to have a means of maintaining a neutral buoyancy, but it is an incredibly flawed strategy as previously discussed. From what can be observed in-game, the floater also doesn't seem to have any means of releasing all the gas that has been built up inside its body. So an obvious change I would make, in order to make the floater more realistic, is to give the floater some kind of means of expunging the gas that it has built up inside it and prevent it from floating towards the surface. But perhaps there is a reason why the floater doesn't expunge the gas it has built up. And perhaps it doesn't need to worry about being stuck on the surface for the simple reason that it might have few to no natural predators. This is, after all, a possibility, but it is rather slim at best. See, most animals will have some kind of predator or other thing that will attempt to eat them, even if they are some of the largest animals on the planet. So I would consider this to be an unlikely possibility, but I will consider it and evaluate the floater with this in mind. The problem this will cause is that the floater still needs a host in order to feed off, and most organisms that live on the water rarely swim close to the surface unless they have one of the following aspects. They breathe air and need to regularly travel to the surface in order to catch a fresh breath, or the prey items that they regularly hunt gather near the surface. And most of the larger creatures in Subnautica, such as the reefback leviathan, I've never observed breaking the surface. This is why I would consider it unrealistic for the floater to be intentionally trapping itself close to the surface and waiting for something to be passing by in order to attach itself to it. The floater does seem pretty unrealistic so far, doesn't it? But what about the later stages of its life? Specifically, what about the ancient floater? Well, here it runs into another problem. See, when an animal grows to a size as big as the ancient floater, it needs to consume large amount of nutrients in order to stay alive. Not grow larger or thrive, survive. And when we find the floater to be this size in the game, it is attached to large underwater islands, and there doesn't seem to be anything in the game that the floater can attach itself to in order to survive. Then what exactly is the floater doing there? Why does it even grow to this size to begin with? I have a few hypotheses that can unfortunately never be verified or tested because I only have very limited interactions with the ancient floater. Regardless, let's speculate. The first, and what I would consider the most likely hypothesis, is that the ancient floater is at the last stage of its life cycle and is preparing to reproduce. This might explain why the floater attached itself to such a large piece of rock and suspends itself in the middle of the water column, as this would maximize the spread of eggs and thus help the species reach a large area as possible by catching onto ocean currents. This hypothesis does have a problem with it though, and that is that one of the floating islands appears to be suspended by the ancient floater alone. Going by the amount of vegetation on the island, it is safe to assume that it has been suspended above the surface for a long time. This would have to mean one of two possibilities. The first possibility is that the ancient floater has a very long reproductive cycle and they stay in this state that they are in for decades if not longer. This seems rather unlikely, as the floater would have to be constantly consuming nutrients in order to maintain its size, and when it has its mouth constantly facing barren rock, this would severely hinder its ability to gather nutrients and thus allow it to grow. It would also be unlikely that the floater grows incredibly slowly. I would argue this because of the environment we find it in, that being warm shallows and the form of its body. What I mean by the warm shallows is that it would not typically allow for conditions, nor does it usually make animals that live exceptionally long life. Rather, it usually has the opposite effect and usually causes animals to live short lives as they grow quicker due to the relatively high temperature. In colder and deeper waters, we are far more likely to find animals with longer lifespans due to the cold temperature slowing down their growth. The other factor, that being the soft body that covers the floater, would not be inducive to a long lifespan either. Animals with hard shells or scales like oysters or clams typically have longer lifespans because of how long their shells take to make and how durable they are. This also makes them extra resistant towards parasites, as they will be difficult for them to get through the hard shell. The other possibility is that the floating island is something of a gathering spot for the ancient floater when it reaches the later parts of its life cycle. This might be more likely, but it comes with some more assumptions. It would have to be assumed that the floater is both a hermaphroditic species, basically it is able to make both sperms and eggs simultaneously and is able to fertilize the eggs themselves. The final thing that would have to be assumed is that the ancient floater doesn't have a reproductive season. Essentially, what that means is that the ancient floater is constantly producing fertilized eggs, meaning that there would be a constant supply of ancient floaters to the island in order to keep it from sinking to the ocean floor. Is all of this realistic though? I would have to say all of these are possibilities, but there's little to no evidence that the floater is actually doing these things. To this end, I can't draw any hard conclusions. Unlike the humpfish, which had descriptions of what exactly the external limbs could do, I have to assume a lot more. This makes the hypothesis and ideas I am putting forth much more based in speculation and thus far more likely to be incorrect. To conclude, I would say that the floater is not realistic and needs a lot more in the way of descriptions and behavior in order to make it realistic. That's all I had for you today. Thank you for watching, and if you like, please like it and comment and subscribe, and I'll see you all next time. Goodbye.